Welcome to the Unit 4 Section 1 video on identifying linear functions and graphing from a table. In this unit, we're going to be talking about linear functions. So let's begin by talking about an example. So the highest speed in the United States is 85 miles per hour, which is posted on a single stretch of tollway outside of Austin, Texas. If a car travels continuously at this speed, y equals 85x gives the number of miles y that the car would travel in x hours. Solutions are shown in this graph. We have time on the x-axis, we have distance on the y-axis, and the distance traveled makes a linear progression if you travel at a constant speed of 85 miles per hour. The graph represents a function because each domain value, or x value, is paired with exactly one range value, y value. Notice that the graph is a straight line. A function whose graph forms a straight line is called a linear function. So let's identify whether each graph represents a linear function. So starting off with A, you can see that this function is indeed a line, so we can say it's linear. This one, even though it's a line, it's a curved line. It's not straight, so therefore it is not a linear function. In this one, we do have a straight line, but we have a special case here because if you recall, what is the definition of a function? A function is a relation where every x value has only one y value. And here we have a whole stack of y values at x equals 3. So this is not only not a linear function, it's not a function at all. All right, for this one, we have a straight line, so it is a linear function. For this one, we have a straight line. It is horizontal. It is a function, so it is not only a linear function, but we can more specifically call it a constant function. And a constant function is a linear function where every x value has the same y value. So no matter where you go along the x-axis, x equals -3, your y value is 4. At x equals 1, your y value is 4. At x equals 3, your y value is 4. No matter where you go, your y value is going to be 4, so we call it a constant function. And then f here, not only is it not a straight line, it's also not a function. So f is certainly not a linear function, and more specifically, it's not a function at all. So just to recap, part E here is a special type of linear function. Because of the value of y is the same for every value of x, it is considered a constant function, and a constant function will always appear as a horizontal line in a graph. You can sometimes identify a linear function by looking at a table or a list of ordered pairs. In a linear function, a constant change in x corresponds to a constant change in y. So here's a table of values. If we take a look at the x values, each time along the list of x values, we add 1. This is a constant change in your x values. We also have a constant change in our y values, or what we're going to end up calling first differences. Because we have a constant change in our first differences, then we have a linear function. So you have to look for a constant change in not only your y values, but also your x values. Both need to be constant for the function to be linear. So now let's do an example determining if each set of ordered pairs represents a linear function. So here we have a set of ordered pairs. We can very easily put this in table format, and then we can see what we have. So starting with our x values, each time we're adding 3, so that is constant. So now we look at our y values. Each time we're subtracting 1. Since we have a constant change in x with a constant change in y, we have a linear function. In B, we're going to take this set of ordered pairs, put them into a table. We do have a constant change in x because we're adding 5 each time, but in the y, we subtract 6 in the first set of y values and then subtract 2 for every subsequent set of y values. So we do not have a constant change in y, so therefore this is not linear. Another way to determine whether a function is linear is to look at its equation. A function is linear if it is described by a linear equation. A linear equation is an equation where x and y both have exponents of 1, x and y are not multiplied together, x and y do not appear in denominators, exponents, or radical signs. So let's take a look at an example. So for each of these equations, we are going to determine whether or not it is linear. So for A, we have a y and an x. Both have exponents of 1. They are not multiplied together, and the y and x are not in denominators, exponents, or radical signs. So therefore, it is linear. For B, we have an x value with an exponent. Since we have an exponent other than 1, it is not linear. The same can be said for C. Again, we have an x value with an exponent of 2, so it is not linear. For D, we have x and y values that are not multiplied together. They do not have exponents other than 1, and they appear in the numerators. They're not in the exponents, not in radical signs, so this one is linear. For E, we do have a fraction, but that x value is in the numerator, not the denominator, which is okay for us to have a linear function. For any 2 points, there is exactly one line that contains them both. This means you need only 2 ordered pairs to graph a line. When presented with a table of values, all the points must be plotted to verify that they represent a linear function. It only takes one point that does not fall on the line to make the table of values nonlinear. So in example 4 here, we're going to determine if the table of values is linear by graphing. So all you have to do is take this table of values, plot your points, and then see if you can draw a line that contains every single one of those points. And since we're able to do that, this function is linear. In example 5, again, you're going to take all these points and you're going to plot them. And then you're going to see if you can draw a line through all the points. Well, as you can see here, we're able to draw a line through 3 of the points, but 2 of the points are not part of that line. Since we're unable to draw a straight line containing all the points, this function is not linear. There are specific characteristics to determine whether a function is linear or not. So let's talk about all of those features that we've talked about in this section. For a graph, you have to have one straight non-vertical line. In a nonlinear function, you'll have a curved or connected lines of varying steepness. In a table-ordered pair, you have to have a constant change in x with a constant change in y. Nonlinear functions will feature a change in x or y that is not constant. And for an equation, linear functions must have variables with an exponent of 1. The variables only appear in the numerator, and the variables are not in the exponent. Nonlinear functions, and by the way, the variables are not in a radical either. Nonlinear functions, variables multiplied together. They feature variables with exponents other than 1. They feature variables in the denominator. They feature variables in the exponent, and they can feature variables inside of a radical. Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.